Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. Welcome to question 10A of this CSET Math exam June 2012 video solution. And in this question we are given a quadrilateral QRST with the dimensions shown on the diagram. Now in this quadrilateral, this diagonal QS resulted in the formation of two triangles. This triangle QRS and this triangle QST. Now in this first triangle we have two known angles and a known side, and in this triangle we have three known sides. So let's get to the questions. So the first question is asking us for the length of RS, that's this side, and therefore we have to work in this triangle in order to find this side. Now this triangle is not a right angle triangle, and therefore we cannot use the trig ratios for sine, cosine or tangent. We cannot use any of those trig ratios, and we also cannot use Pythagoras' theorem. Pythagoras' theorem and the trig ratios are only valid for a right angle triangle. Now because this triangle is not a right angle triangle, we have to use either the sine rule or the cosine rule, and we typically use the sine rule once we have a known angle and a known opposite side, as we have here. We know this angle is 60 and we know this opposite side to the 60 degrees is 7 centimeters, and then we want to find this side and we know the angle opposite. So this is a typical case for the use of the sine rule. Once we have a known angle and a known opposite side, we can use the sine rule. So let's go ahead and show that. So we are going to be using the sine rule to calculate the length of RS, and let's just have a look at the sine rule. And this is it here. In this triangle we have a capital A representing this angle and the opposite side being represented by a common letter A. And here we have a capital B representing this angle, and the side opposite is designated with a common letter B. And the sine rule says that the side A, which is here, divided by the sine of the angle opposite, which is this angle, is equal to the side B, which is here, divided by the sine of the angle opposite. So we can go ahead and apply this sine rule to this triangle here. So let's go ahead and show that. And this is it. The side RS here divided by the sine of the angle opposite, which is 48 degrees, will be equal to the side 7, which is a known side, divided by the sine of the angle opposite, which is 60 degrees. That is RS divided by sine 48 equals 7 divided by the sine of 60. The side divided by the sine of the angle opposite equals the known side divided by the sine of the known angle, which is opposite to the known side. And so if we transpose this equation to make RS a subject, we end up with RS equals 7 multiplied by the sine of 48 degrees divided by the sine of 60. We simply multiply both sides by the sine of 48 degrees, and this is the result. And when we use our calculator to work out this value, we see that the length of RS is 6.01 centimeters. And that is the answer for part 1. Let's move down now to part 2. Now part 2 is asking us to calculate angle QTS. That's angle QTS. That's the angle right here. So let's call that angle theta, and we will mark that angle theta on the diagram. And that is it. Angle QTS, we are calling that angle theta. Now we have to use this triangle QTS to find angle theta. And here again we have a triangle that is not a right angle triangle, and therefore we cannot use Pythagoras' theorem, and we cannot use any of the trig ratios, the sine trig ratio, the cosine trig ratio, or the tangent trig ratio. We have to use either the sine rule or the cosine rule. Now in this case, we cannot use the sine rule because we have no known angle. In order to use the sine rule, we must have a known angle and a known opposite side. Here, what we have the three sides, and we have two sides and an included angle here that we are trying to find. And that is typically the case for the use of the cosine rule. We typically use the cosine rule when we have two known sides and an angle between two known sides and an included angle. So let's go ahead and show how this theta can be calculated using the cosine rule. And this is it. We'll be using the cosine rule in this triangle to calculate angle theta. But let's have a look at the cosine rule. And this is it. When we have a triangle with two sides, that's B and C here, and an angle between those two sides, that is a typical case for the use of the cosine rule. And if the angle between the sides B and C is given the letter capital A, then the side opposite to that angle is designated common A, and we have the cosine rule here. The opposite side to the angle squared is equal to the sum of the square of the two sides B and C, as we have here, minus twice the product of the two sides multiplied by the cosine of the angle between the two sides. This is a cosine rule, and we can go ahead and apply the cosine rule in this triangle QTS, and let's show that. And this is it. The side opposite the angle, which is 7 squared, is equal to this side squared plus this side squared. That's what we have here, 8 squared plus 10 squared, minus twice the product of those two sides, twice the product of 8 and 10, multiplied by the cosine of the angle between the sides, 8 and 10. That's the cosine rule. And so all we need to do now is transpose this equation to calculate theta. So here we have 2 multiplied by 8, that's 16. 16 multiplied by 10 is 160. So this would be minus 160 cos theta. So what we'll do, we'll take this negative 160 cos theta on this side of the equation, and we'll take this 7 squared over to this side of the equation and subtract it. And when we do that, this is the result. We end up with 160 cos theta equals 8 squared plus 10 squared from here. And when we subtract the 7 squared on this side, and then all we need to do now is divide by 160 and then take the inverse cos. So we're going to end up with cos theta equals this divided by 160, and therefore theta equals cos to the minus 1 of this divided by 160. So let's show that. And this is it. Theta is cos to the minus 1 of this expression here divided by 160. And when we calculate these values, we see that the angle theta is 44 degrees. That is it. Angle QTS is 44 degrees. And that's the end of this part of the question. Let's move down now to part B. Now in this question, we are given a circle, center O here, the line UVW is a tangent, and ZOXW is a straight line. We're also given the angle at the center here, UOX. That angle is 70 degrees. And the question basically wants us to calculate some of the angles. So what we're going to do is show some observations, label the angles, and then calculate the value of the angles. Now the first thing we want to observe are our isosceles triangle. Because this is the center of the circle, it means that this line is a radius, and this line also is a radius, and therefore this is an isosceles triangle, and that's what we have here. OUX is an isosceles triangle. Also, this triangle is isosceles because this is a radius and this is a radius, and therefore this is an isosceles triangle. This triangle also is isosceles because this is a radius and this is a radius, and so this triangle is isosceles. So that's it. We have identified the isosceles triangle. So we can go ahead and label these isosceles triangles such that the base angles are shown to be equal. And this is it. We'll call these base angles in this isosceles triangle alpha, These two angles are opposite angles, so we'll designate both of them as phi. As we said, this is an isosceles triangle. This is a radius and this is a radius, and therefore this base angle we call it theta, and so this one also will be theta. Now these two isosceles triangles are identical. It means that the base angles here and here will also be theta. So we can go ahead and label those angles theta as well. Now this angle, we will label that angle as beta because we'll be required to calculate that angle, and we will label this angle omega, another angle that will be required to calculate. So let's go now and show the calculation of each of those angles. Now firstly, in this triangle, the total angle in this triangle is 180 degrees, and we can show that total angle in triangle OUX is 180 degrees, and therefore 2 alpha plus 70 is 180 degrees, and therefore to calculate alpha we subtract 70 from both sides. We would get 110 and then divide by 2. So alpha is 110 divided by 2, that's 55 degrees, and so these two base angles in this triangle are each 55 degrees. So let's go ahead and show that. And that's it. Those two angles are 55 degrees each. And now, total angles on this straight line here through O is 180 degrees. Right? So let's go ahead and show that. Total angles on a straight line is 180 degrees, and therefore 70 degrees plus phi here must add up to 180 degrees. And that's it. Phi plus 70 degrees is 180 degrees, and therefore phi is 180 degrees minus 70 degrees. This is a straight line, just as this is a straight line, having the same angles phi and 70 degrees. And so in each case, phi is 110 degrees. So we can show that. And then in each of these triangles, the total angle is 180 degrees. And that's it. Total angle in triangle OUZ, that's this one, and also in triangle OXY, that's this one, total angle in each case is 180 degrees. And so 2 theta plus 110 degrees must be equal to 180 degrees, and that's it. 2 theta plus 110 degrees is 180 degrees, because total angles in this triangle is 180 degrees, and also in this triangle the total angles is 180 degrees. And so to find theta, we subtract 110 degrees first, we end up with 70, and then divide by 2. So theta is 70 degrees divided by 2, which is 35 degrees. And that's it. Theta is 35 degrees. So we can show that on the diagram. And that's it. 35 degrees here, 35 degrees here, 35 degrees here, and 35 degrees here. And the first question asked us for this angle OUZ, and we have worked that out to be 35 degrees. So that's the answer for the first angle that we're required to find. Angle OUZ is 35 degrees. Let's continue on the next page. Now, this is the information we have so far, and now we're going to proceed to try and find beta, which is the next angle we're required to find. Angle UVX, which is beta. Right? Now, this is a tangent and this is a radius, and the angle between a tangent and a radius is 90 degrees. So let's go ahead and show that. The angle between the tangent UV and the radius OU is 90 degrees. The angle between a tangent and a radius is 90 degrees, and so this angle here is 90 degrees. So we can go ahead and show that angle OUV is 90 degrees, and therefore this is a right angle triangle. This triangle here, YUV, is a right angle triangle, and therefore this angle and this angle must add up to 90 degrees, because this angle is 90 degrees. So we can show that. That is it. Triangle UVY is a right angle triangle. And therefore, beta, angle beta plus 35 degrees equals 90 degrees. And so beta is 90 degrees minus 35 degrees, which is 55 degrees. And we can go ahead and show that on the diagram. Beta is 55 degrees. Now also, we're required to find angle here, omega. And we recognize again that this triangle is a right angle triangle. That's OUW is a right angle triangle. And therefore, this angle here plus this angle here must add up to 90 because this angle is a right angle 90 degrees. Right? Let's go ahead and show that triangle OUW is a right angled triangle. Triangle OUW is a right angled triangle, and therefore this angle plus this angle add up to 90 degrees, and that's it. And therefore omega is 90 minus 70 degrees, and that angle is 20 degrees. So let's show that on the diagram. Omega is 20 degrees, and that's it. And so now we can show the answer for part B and part C of this question. We're asked to find angle UVY. Angle UVY, that's this angle here, which I have calculated to be 55 degrees. And we're also asked for angle UWO, that's this angle here, which we have calculated to be 20 degrees. So that's the answer for that part of the question. Let's move down now to the second part of question 10b. Now question 10b is asking us about congruent triangles in this diagram. Now let's talk about congruent triangles a bit. Now two triangles are said to be congruent if they are identical in every way. That is, if they have equal angles and equal sides, and so they would have equal areas. And we can deduce that two triangles are congruent if we have any of these conditions. If we have three sides on one triangle being equal to three sides on the other triangle, then those two triangles are congruent triangles, equal in every way. Secondly, if we have two sides and an included angle on each of the two triangles being equal, that is, if two sides and the angle between those two sides are equal on each of the two triangles, then the two triangles are congruent triangles. And thirdly, if we have two angles and one side on each of the two triangles being equal, then the two triangles again are congruent triangles. So let's look at the congruent triangles in this diagram. Now first, we want to find the triangle that is congruent to triangle ZOU. That's this one, triangle ZOU. Now in this triangle, we have two radii, and the angle between the two radii is 110 degrees. And if we look at this triangle over here, triangle YOX, we also have two radii here and here, and the angle between them is also 110 degrees. So these two triangles satisfy condition 2, that is, two sides and an included angle of each are equal. We have two radii and the angle between them is 110 degrees in this triangle, and in this triangle we have two radii and the angle between them is 110 degrees. And so this triangle and this triangle are congruent triangles. So the triangle that is congruent to triangle ZOU is triangle YOX. Triangle YOX is congruent to triangle ZOU. And then we're asked which triangle is congruent to triangle YXU. That's this one, triangle YXU. That's this triangle here. Now this triangle, we have a diameter. The angle at this end of the diameter is 35 degrees, and the angle of this end of the diameter is 55 degrees. If we look at this triangle here, we see we also have a diameter, and the angle at this end is 35 degrees, and the angle at this end is 55 degrees, similar to this triangle. So this triangle here, triangle ZXU and triangle YXU are both satisfying condition 3 for congruent triangles. they have two angles and one side equal, right? The diameter here is equal to the diameter here. The 35-degree angle here is equal to the 35-degree angle here. The 55-degree angle down here is equal to the 55-degree angle here, and therefore the triangle that is congruent to YXU is triangle ZUX. And we can write that. Triangle ZUX is the triangle that is congruent to triangle YXU. And that is the answer for this part of a question, and that is the solution for question 10. And we'll do question 11 in our next video. Okay, see you then. You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.